All right, today we are going to be working on similar figures, which we're going to learn to determine whether the figures are similar. We're going to learn to use scale factors, and we're also going to find missing dimensions in similar figures. Now, we do have 3 vocabulary words. Our first vocabulary word is similar, which similar is figures with the same shape but not necessarily the same size are called similar, which basically means same shape, not necessarily the same size. Okay? Congruent angles. Congruent angles are angles that have the same measure. Remember, congruent means basically equal. Okay? That means the exact same. And our last one is scale factor. A scale factor is a ratio used to enlarge or reduce similar figures. All right, let's take a look at our first slide here. It says similar polygons. The words for that are going to be, for 2 polygons to be similar, corresponding angles must be congruent and corresponding sides must have lengths that form equivalent ratios. Now, what does all that mean? Well, let's take a look at our diagram right here. If you notice, in our 2 triangles there, all the angles are the same. Okay, if the angles were not the same, it will be a different shape, therefore they would not be similar. Okay? Then our corresponding parts, it tells us that angle A equals angle E, angle B equals angle F, angle C equals angle G, and then it gives us all of these fractions right here. What do those fractions mean? Well, let's take a look. This first one right here, AB, it's talking about this side right here. Okay? It's saying side AB which is 60, and side EF, which is this side on this triangle right here, those are our corresponding sides, is 30. Okay? Then it's saying that side BC, which is this side right here, which is 48, and side FG, which is this side right here, which is 24, and then finally side AC, which is this side right here, which it says is 36, EG, this side right here, which is 18. Okay? It's telling us those all equal each other. And if you look at it, yeah, they do, because all of these sides right here equal 2 over 1. Whenever we simplify that, 60 over 30 is 2 over 1. 48 over 24, 2 over 1. 36 over 18, 2 over 1. That's how we tell these shapes are similar, because all of the sides are proportional. If we were to get one of these, like let's say the 60 over 30 wasn't 60 over 30. Let's say it said 60 over 35. That means these 2 triangles would not be proportional because we have a side lengths that aren't proportional. Yes, sir. No, you can't add or subtract. Okay? Because when you start getting in trouble when you start adding and subtracting, it has to be multiplying or dividing. Okay? Because you have to do the same thing at the top that you do to the bottom. Which we don't, because if you do 60 minus, well, 6, that doesn't equal 48. You know what I'm saying? Well, yeah, but down here, if you did 30 minus 12, does that equal 24? No. But you have to do the same thing at the top that you do to the bottom. Okay? So that's why. All right, let's take a look at our first example. It says, which rectangles are similar? Well, in order for us to determine which one of these are similar, we have to first identify all the corresponding sides. And when I say corresponding sides, I mean like the same side on a different shape. Like these are kind of easy because all the rectangles are already arranged for us. Okay, they're all sitting on this base right here. Okay, and the side right here, they're all sitting tall ways. Now, the shapes won't necessarily do that all the time. Like if you look, these triangles right here are similar, but they've been rotated around. So you have to know that, you know, your right angle is pointing at your hypotenuse right there and right here. So you have to know that those are the 2 sides that are going to be corresponding. These rectangles aren't that difficult. Now, to determine which one of these are similar or which ones are not, what we have to do is we have to make, well, ratios out of these. Okay, and the ratio we're going to make is I'm going to make the blue side over the red side. It doesn't matter. We could do red over blue if you wanted to. It doesn't really matter. So I'm going to do, for this one, it's going to be 10. For this one, it's going to be 5. For this one, it's going to be 12. And those are going to be over my red side, which for that one's 4. For this one is 2. And for this one is 5. Now, what it's asking us to do is determine which one of these ratios are equal to each other. Whenever we determine which ones are equal to each other, that's which ones are going to be proportional. Well, 10 over 4 here, if we simplified that, that would give us 5 over 2. Hey, look, we got 5 over 2 over here, too. So that one, I mean, obviously this one and this one are, but let's take a look at 12 over 5. Well, 2 won't go into both of those, so we can't simplify that one any more than it is. So, triangle J and K, yeah, sorry, I did that in the first class also. Rectangle J and K are similar because the proportions equal each other. Okay? Does that make sense? Okay? All right, let's take a look at the next example. This one is talking about scale factor. It says a picture is 10 inches tall and 14 inches wide. It's going to be scaled to be 1.5 inches tall to be displayed on a web page. How wide should the picture be on the web page for the two pictures to be similar? Well, what I'm going to do is I'm going to draw my two rectangles out here so I can determine the sides. Helps me identify it. Okay, it says the picture is 10 inches tall, so I'll make this 10 right here. 14 inches wide. I'll put 14 right there. And we're going to scale it to where it's going to be 1.5 inches tall. So this new number right here is going to be 1.5. Okay? And it's asking us, that's the question it's asking us. It's saying, well, how wide is that picture going to be on that web page? Okay? So in order to figure this out, they showed you what you could do is, they're saying, well, we're going to figure out the length of this side by finding the scale factor. Okay? So what they did is they said, well, this number right here, we divided by 10 to get something. That's our scale factor. Okay? What they did is they did 1.5 divided by 10 and gave us 0.15. Now, when we get that, that would be our scale factor right there, 0.15. Okay? So then they took 14, which was this side right here, multiplied it times 0.15, and that'll give you your missing side, which is 0.21. Now, if you don't want to do it that way, because to me that's a little bit more confusing than using the proportion method, and that's what I'm going to show you right now. We could still do, like we could do the blue side over the red side and make proportions out of this, just like what was on your assignment last night. Okay? Now, once we have that set up, now, how did I set this up? Well, I made sure the blues were on the top, the reds were on the bottom. It doesn't matter which one is on the top and the bottom as long as the corresponding sides are next to each other. Meaning I could have put the reds up here, but I would have had to have had the 10 and the 1.5 up top and the 14 on the bottom. Okay? You'll get the same answer. Now, once we have this, we can do just like what we were doing before. We can cross multiply. 14 times 1.5 actually gives us 21. And then 21 divided by 10 gives me 2.1. So I know that this side over here is going to be 2.1. I like doing it that way myself, but clearly it's up to you. To me, I like setting up the proportion, cross multiplying, and dividing. I think that's a simpler process, and I think that you guys understand that a little bit more. But I would always, on these word problems, if it doesn't give you the shapes, I would always draw the picture because it makes it certainly a lot easier for you to see. All right, questions on that? No? All right, then let's take a look at these last couple of examples. You don't have to write these down. Just pay attention to make sure you understand what you're doing. Okay? Let's take a look at the first one here. It says we have a rectangular house that is 32 feet wide, 68 feet long. On a blueprint, the width is 8 inches. Find the length on the blueprint. So again, if we have these big rectangles down here, okay, one is 32 foot wide, 68 feet long. Down here it's 8 feet. And that's what we're looking for right there. Okay, we could do the same thing to this one, find our corresponding sides that we did on that last one. Now I'll set it up. Look, I'll have 68 over, yeah, well, no, that's not 7, that's a question mark. Sorry. And then I will go ahead and put my green sides on the bottom here, so we'd have 32 right here, 8 right here. Okay, now once we have that, now we can cross multiply and divide. But I will tell you on this one, if you notice, look, what times 8 equals 32? 4. So we know some number, this question mark right here, the some number right here, times 4 has to equal 68. So if we did 68 divided by 4 on this one, it will give us our answer. Okay, that'll work also. Which actually 68 divided by 4 is, what, 17? So we know that the length on this one right here is going to be 17. Well, you could certainly, I mean, basically, you could always cross-multiply these two numbers and check them if you wanted to, because if they equal each other, then you got it right. If they don't, then you got it wrong. Okay? But that would certainly be a good way to check it, yeah? Questions on that one? No? Okay, so, all right, sure, what we get? 17 for that guy. All right, well, let's take a look at our next example, number 2 here. It says, Karen enlarged a 3-inch wide by 5-inch tall photo into a poster. If the poster is 2.25 feet wide, how tall is it? Well, again, I would start out by drawing my pictures. Okay, so we're going to have 3 inches wide, 5 inches tall, and then over here we have 2.25, and then our question mark. Okay, again, we'll start with the colors. Okay, set up your proportions, which, let me see what we could do, 3, and then 5, and then our question mark. Okay, from there we cross multiply and divide. That'll give us our answer. Okay, questions on that? It is easy. Okay, number 3, again, we're going to do the same thing on that, just identify the size and find out which ones equal each other. It's possible that all 3 of those could be proportional, but it's also possible that none of those 3 would be proportional. Okay? Questions on that? No? All right. Then